Okay, welcome to Friday. Hey, if you have not taken the quiz, you were supposed to take the quiz first. So go ahead and pause the video, take 15 minutes, take the quiz, and then come on back to the lesson. Okay, so everyone's taking the quiz. You already can see what your results were. For those of you that did poor, I don't have it yet, but um, by next class, I'll have a reteaching. So you'll just have to send me. I'll remind you at the next video as well. You just have to send me an email saying, hey, I want to take a retake, and I'll give you a reteach, give you a worksheet you got to do, and then if you're ready for taking a retake, you can. All right, so your homework for Wednesday was the Pythagorean theorem in 3D worksheet number 2, or for day 2. All right, let's go over the answers here. Questions 1, 2, 3, and 4 all had 3 problems for each one. So I'm just going to go from left to right. Question number 1, the 3 answers were 15, and these are approximations, right? I had a couple people email me, hey, what do you want me to round to? I didn't specify, so you were free to round to whatever number you wanted to. I rounded all mine to the nearest tenth. So let's see, the first 3 answers are 15.7 inches, 6.1 meters, and 13.4 inches. For question number 2, 14.1 meters, 8.9 inches, and 11 inches. Question number 3, 12.5 yards, 12.8 yards, and 9.8 centimeters. Question number 4, 9 inches, 6 kilometers, and 10 miles. The last one, the box ones, what's the longest object you can fit inside the box? There were 4 here, top to bottom, left to right. 15.6 inches, 17.5 yards, 16.4 kilometers, and 11.8 centimeters. So count up how many you got wrong. Please answer question numero uno. Nummer eins, number 1. Okay, so we just took our quiz. We just graded our homework. We're moving on to remember this AD. It's not in the book. It's an additional lesson. This is actually in the book as just doesn't have a name to a section to it. This is going to be something called the distance formula. So if you look at the bottom of the Google Forms, you'll see the worksheet. This is probably the longest formula you'll ever see, at least until you get to Algebra 1 next year. So this is the longest formula we will do of the year. Okay, so the section is on distance and midpoint. We're just going to do distance today. We'll do midpoint tomorrow. And yeah, you're going to like this form. It's kind of cool. All right, so one objective, can I find the length of the segment? So here's the big picture. The big picture is this. I'm going to give you a segment. And the segment obviously is defined by 2 endpoints. You can see here endpoint G and endpoint J. So the distance between G and J. G is at 0, -6, and J is at 4, -6. And there will be 2 questions that I will ask. How long is that segment? And where's the middle of the segment? That's the distance and the midpoint. Well, when the segment is horizontal, you don't need any formulas. How long is it? Well, it looks like it's 4 squares long, so therefore it's 4 units long. Where is the midpoint? Well, it's pretty easy to see where the midpoint is. So the midpoint is at 2, -6. Okay, so finding the distance and the midpoint when you have a horizontal or a vertical line segment is a pretty simple thing. But if it's not horizontal and vertical, for instance, this one, I mean, how do you determine how long that is? How do you find the midpoint? Thus, we need a new method. So we need a new method, but the 2 questions we'll be answering today and on Monday is how long is this segment and where's the middle? So the answer to how long it is, we will arrive using something called the distance formula, and where is the middle? We'll get a smaller formula, an easier one, called the midpoint formula. So the distance formula, okay, so you're going to like this. Here's where it comes from. So here's a diagonal segment, right? It's really hard to figure out how long that thing is, but here's the trick. I simply extend a line segment from E, right? Remember, I'm answering how long this is. So I simply extend the segment from E in this direction. You see what I did there in black? And then I extend the line segment from F downward, and guess what I just made? I made a right triangle. And remember, we can count how many squares there are when there is a horizontal or a vertical line segment. So the vertical part is 3, the horizontal part is 4. It's just a right triangle. We use the Pythagorean theorem. So 3 squared plus 4 squared equals c squared. Okay, and you've done this one plenty of times. In fact, that was what the quiz was on today, Pythagorean theorem. So I can find out the distance of that line segment is 5. Let's see that again. How long is this line segment? All I do is extend the segment on the bottom. I extend it vertically. I count the number of squares, right? So the bottom line segment that's black is 5 segments long, or 5 squares long. The vertical portion right there is 2, so I get A and B are 5 and 2, so 5 squared plus 2 squared would equal c squared. I use the Pythagorean theorem, and I get to the answer. Great! But we're not going to be using a graph. We're going to be doing this process simply from the two endpoints. I'm going to give you the two endpoints. You're not going to use a graph. You're not going to have to graph this. You're just going to find its distance using something called the distance formula. So what's the distance between those 2 points? Well, take a deep breath, and I'm going to show you where the formula comes from first. So we know the formula is going to use the Pythagorean theorem. So the formula will be the Pythagorean theorem, but I'm not going to give you a graph. So let's think about this. We need to figure out how far it goes horizontally and how far it goes vertically. Well, maybe some of you already realize this. Take a look at the x-coordinates there. Well, the x-coordinate of F is 7, and the x-coordinate of E is 2. Do you see where I'm getting those numbers, 7 and 2? We already knew that horizontally it went 5 units, right? Well, that's what 7 minus 2 is. 7 minus 2 is 5. Now look at the y-coordinates. The y-coordinate of F is 3, and the y-coordinate of E is 2. Well, I know it's 2. Why? Because 3 minus 1 is 2. This is where I'm getting these numbers from. So I don't need a graph. All I got to do to find the distances for the 2 legs of the triangle are subtract the coordinates. Okay? So yes, we're going to have a formula. And unfortunately, it's going to be a long formula. So here's what I need you to do. I need you to write this down. I'll show you the formula here. Don't panic. It is complicated, but it's just the Pythagorean theorem. So we're going to take the idea of what we just did of subtracting the x and the y coordinates and the fact that it is the Pythagorean theorem. So we take the square of a, the square of b, add them together, and take the square root. Yeah, that's the distance formula right there. D for distance is equal to, well, what's the last step of the distance, or of the Pythagorean theorem? It's to take the square root. So eventually we take the square root. How do we find the 2 legs? Well, we subtract the x-coordinates, then square it. Then we subtract the y-coordinates and then square it, and then add those sums together. That's where that formula comes together. Don't panic. We're going to do plenty of examples here. So I'm going to start this off once you have this written down just by showing you how this works. So once again, here's the big picture. I'm going to give you 2 points. They could be A, B, they could be E, F, whatever. I'm going to say how far is it between point A and point B. Okay, so you see the 2 points there, A and B. We're not going to graph it. I'm just going to give you A and B and say what's the distance between A and B. So all you're going to do is plug these values into the equation and then just evaluate that equation for those values. So here's how it works. Step number 1, I do need you to label. I really need you to label X and Y, so you don't mess up the numbers. Okay? You got to determine which one is your point 1 and which one is your point 2. Well, I'm kind of lazy. I just always call the first one point 1 and the second one point 2. You may label the top one point 2 and the bottom one point 1. You'll still get to the same answer. Okay? Then all you do is you plug those values into the equation. Well, if we go from left to right, it says D equals and a big long square root symbol. So we write that. Then you have an open parentheses and some squaring plus an open parentheses and some squaring. And then we plug in the values. The first thing it asks is for x2 or x sub 2. That means the x-coordinate of point 2. So you find the x, you find point 2. The x-coordinate of point 2 is 7. Do you see where I'm getting that number from? 7, x-coordinate of point 2. Subtract the x-coordinate of point 1. So the x-coordinate of point 1, x-coordinate point 1 is 2. Now I need the y-coordinate of point 2, the y-coordinate of point 2. So I find y, And then 0.2, well, that's a 3, minus the y-coordinate of 0.1. The y-coordinate of 0.1 is 1. Now I've plugged in all my numbers. Now I just have to follow PEMDAS to get to the answer. 7 minus, we got to do inside parentheses first. 7 minus 2 is 5. 3 minus 1 is 2. 5 squared is 25. We got to do exponents next. 5 squared is 25. 2 squared is 4. We have to do what's in underneath the square root symbol next. 25 plus 4 is 29. We grab our calculator and we get to the answer. Okay? And notice I'm doing some rounding here, so about 5.4. So that's how it's done. Okay. The nice thing here is you're going to be able to pause this, rewind this, play this many times until you catch on. Some of you may have caught on in the first example. So here it comes. Step number 1 is to label. So you got to label x, y. And then you got to figure out which one you want to be is 0.1, 0.2. There is some strategy involved. I'll let you guys figure out what the strategy is. Sometimes it makes it better to put the first one as 0.2 and the second one as 0.1. But if you don't need to worry about strategy, if you just label them and you're consistent about it, you will get to the right answer. Okay. So let's see. I got to write d equals big long square root symbol, open parentheses, and then I need x sub 2. X sub 2 is 1. Minus x sub 1. X sub 1 is 6. So 1 minus 6 squared plus y sub 2 is 9. And y sub 1 is 3. So pause the video. Look at the values. Look at what numbers I plugged in where. Make sure you understand why those values go where they did. The rest is just some math. 1 minus 6 is negative 5. 9 minus 3 is 6. Negative 5 squared, or parentheses, negative 5 squared is 25. 6 squared is 36. 25 and 36 is 61. Grab your calculators. Square root of 61 is about 7.8. Okay? Cool. All right, for those of you who know what you're doing, go ahead and pause the video. Get to the answer before I get to it. For those of you who need some help, well, let's do it one step at a time. One step at a time. Here we go. First thing is label. And for those of you that are lazy and you don't label, eventually you'll plug the numbers in the wrong order and you'll make a mistake. So make sure you plug in the numbers correctly. You got to label 1 as 0.1 and 0.1 as 0.2. I do it this way. Some people will just put 1 and 2. They don't want to write the word 0.1, 0.2, and that's fine as well too. Just don't confuse yourself. All right, so x sub 2 is 2. X sub 1 is 3, so 2 minus 3. Y sub 2 is 4. Y sub 1 is 8. So I get 2 minus 3 and 4 minus 8. Pause the video. Make sure you understand where those numbers came from. Now I do the math. 2 minus 3 is negative 1. 4 minus 8 is negative 4. Negative 1 squared is 1. Negative 4 squared is 16. 1 plus 16 is 17. Square root of 17. It's about 4.1. Getting to be pros at this? So who wants to take a guess at when this would become a more challenging problem? When would this become more challenging? What do you think, Sarah? Sarah said this will be more challenging if there are negatives involved. Yeah, negatives involved is when it becomes more challenging. All right, so here we go, negatives. This is where 9 times out of 10 you'll make a mistake when there's negatives involved, because that subtraction is still subtraction. You got to keep that subtraction in the formula. So you're going to have multiple negatives running around. I tried to make this one nice and ugly. So here we go. I've already got them labeled. So let's see. X sub 2 is negative 4 and x sub 1 is negative 1. So I get negative 4 minus 1. Holy cow, that's a lot of minus signs. Minus 4 minus 1. Y sub 2 minus y sub 1 would be minus 6 minus 3. Pause this. Make sure you understand what happened there. Okay, for me, let's see. Minus 4 minus 1. So minus 1, 2 negatives make a positive. So that will be minus 4 plus 1. Minus 4 plus 1 is negative 3. And minus 6 minus 3 would be negative 9. Make sure you understand why I got those two values. 2 negatives make a positive. That first one with the x ones. Minus 4 plus 1 would be negative 3. Minus 6 minus 3, same sign, so you add the two numbers. All right, the squaring the rest is pretty simple. 3 squared is 9. Notice whenever you square a negative, you get a positive. And negative 9 squared is 81. So this is 9 plus 81, which is 90. And the square root of 90 is about 9.5. Cool thing about this is that you can always pause, slow down. So don't assume that you got to listen to the whole thing. You can hit the pause button at any time. What are the hard ones? The ones that have negatives. All right, so one more with some negatives. All right, I've already got them labeled. If you know what you're doing, go ahead and pause the video, get to the answer, and then check your work. Let's see. X sub 2 is negative 1. X sub 1 is 2. So that would be negative 1 minus 2 plus, let's see, y sub 2 is negative 7. Y sub 1 is negative 8, or minus 8, sorry. Minus 1 minus 2 is negative 3. Minus 7 minus 8 is negative 15. Hey, remember back when we were doing chapter 2 and you guys were first doing negative numbers and you're all having problems and now it's not even a big deal? Yeah, that's what happens after a year of messing around with negative numbers, so that when you get to Algebra 1, we don't have to worry about negative numbers. We just all know how to do them. All right, negative 3 squared is 9. Negative 15 squared is 225. 225 and 9 is 234. Square root of 234 is about 15.3. Okay, for those of you that are like, I got this, Mr. C, drive on. Do the next one. The next one you're going to have to answer on the Google Forms. For those of you that are like, I need to see a couple more of these, just rewind, especially the ones that have negatives. Do the ones with positives a couple times, and then when you do that, then you can go on to the negative ones, and they'll make a bit more sense. So just remember, 2 negatives make a positive, so a couple of the times you'll get 2 negatives. All right, so here's what I want you to do. I gave you one that's just everything's positive. I just want to reiterate for those of you that like, man, that's a weird formula. Where does it come from? It's really just the Pythagorean theorem. That right there is the Pythagorean theorem. You're like, well, that doesn't look like the Pythagorean theorem. Let me explain it to you. Well, that is the Pythagorean theorem right there. A squared plus b squared equals c squared. All they do is, remember, we're trying to find the distance of a segment. So instead of calling the segment C, they call the segment D, right? To get rid of squaring, you take the square root of both sides. So if I took the square root of both sides, it would look like this. So now that last part right there kind of looks like the distance formula, except for the x's and the y. Well, remember, A was the horizontal distance, B was the vertical distance. And how do you find how long something is horizontally and vertically? You just take the coordinates, you subtract them. That's why a squared is actually x2 minus x1 squared. And b squared is actually y2 minus y1 squared. Okay? So really what we're doing here is just the Pythagorean theorem. So this is an application of Pythagorean theorem. And I will just say, for those of you that are going into technical fields, anything dealing with computers, the distance formula is widely used. I mean widely used. If you take any standardized test, one of the formulas on their formula sheet will always be the distance formula because it's used so often. It's very useful. There's also one for this. This is in 2 dimensions. There's also one in 3 dimensions. You could guess what it would look like in 3 dimensions. All it does is add a z. So there would be a plus z2 minus z1 quantity squared as well too. And that would be the distance formula for any object in 3 dimensions. And so whenever a computer calculates the distance of something, they take the coordinates of the 2 endpoints and they simply use the distance formula. And that's how it's done. Okay. So that kind of ends the last thing, but I do want to throw this one what if. And I believe there's one problem like this tonight for homework. So what if you had a shape, right? Instead of just a segment, you had a shape, and they ask you what the perimeter was. Right? Well, if you could take the shape and place it on the coordinate plane, well, we could calculate the perimeter of that. We would simply need to know the 3 endpoints. Well, the 3 endpoints, the vertices of the segments, well, we can get that one. The first one is 0, 2. The second one is 5, 0. And the last one is negative 3, negative 1. Well, once we have that, for each individual piece's parts, we could use the distance formula. So, for instance, if I had A, which is 1, 2, B, which is 5, 0, and C, which is negative 3, negative 1, I could calculate the distance of, for instance, AB. Right? If I were to calculate the distance of AB, right, we'll call that the first side, right? So that would be the distance between A and B. I'm not claiming that distance is 1. I'm just saying that's the first side I'm going to do the distance formula for. I would do the distance formula for A and B, right? I would find a value. Let's just say it's 4. It is 4.5, by the way. And then I would go to a second side. Let's say CB. So then I would take the distance between C and B, or B and C. That would be side 2. I would use the distance formula to find the distance between the two, and then I would do the same thing for the third side. Third side is CA or AC, so I need to use those two values for the third side. I do the distance formula to find out, in this case it's 5, and simply add those values together. Now, that would be how you would find the perimeter of a shape. Now this won't work for a circle, but it will work for all polygons if the polygons are placed on the coordinate plane, or they give you the coordinates if they say what A, B, and C are. Okay? All right. So that's where we're going to end it today. Your homework is a worksheet. It is on the bottom of the Google Forms. So that's your Friday work, and I will see. Hopefully, you guys did well on the quiz. More to hear about the quiz on Monday. So I will see you guys on Monday.